How's it going, guys? We're going to go over calculating the mass percent composition of a couple different compounds. We'll start off with this one, Al2CO3 3. And let's just say we're going to try to find the mass percent composition of oxygen. So first off, if we calculated the let's see here, if we calculated the molar mass of this, which we did actually do in the last video, we'd find it to be 234 grams per mole. If you did the calculation right before you calculate the mass percent composition, it'll actually help you because you'll know how to fraction it out. But basically, if we already are given the molar mass, let's just figure out how many oxygens there are. So 3 times 3 is 9. So there's 9 oxygen molecules. And let's figure out now what that actually equates to. So 9 oxygens, and the mass of each one is 16, equals 144. And that's how much the oxygen equates for in this. So it's basically like figuring out the percentage of anything else, or like how well you did on an exam. You divide how many you got right by the total number. So we're going to have 144 divided by the total, which is 234 times 100. So it's a pretty straightforward. 144 divided by 234 equals that times 100. It's 61.5. We can round up to 54. 61.54. So what the relevance of that is, of the mass of this entire compound, 61.54% of that weight is from oxygen. So now we'll do a larger molecule. Let's see here, 2952. If you watched the last video, you will recognize this molecule. And see, 12 O is 832, S is 8, and Fe is 4. I hope that you don't actually have to do this on a test, but yep, that is hemoglobin. Alright, so here we go. We're going to, let's say we're going to try to find the mass percent. Oop, that doesn't look very pretty. Mass percent composition of, let's say, I don't know, hydrogen. In the previous video, we calculated the molar mass of this molecule to be 65,248 grams per mole. And we're going to take that and then compare it to hydrogen. So now we have, it's nice and easy, we have 4,664 of them, but each one we rounded down just to 1 grams per mole. So that's going to equate to 6,664 grams per mole, and then we're just going to plug that right into this formula just like we did last time. So the total is on the bottom, 65,248 grams per mole, and then on top we're going to have 4,664, which is, again, this is the total, and this is just what we're looking for. The mass percent composition in this case is hydrogen. And then all that is times 100. So we have 4,664 divided by 65,248 equals that times 100. We get 7.15%. And that means that of this whole molecule of hemoglobin, 7.15% of its total mass is from hydrogen. All right, cool. I hope this helps someone.